Fine. What did we do yesterday? What was the topic we completed? Till cyclic we did? Okay, fine. So once again, before we start from yesterday, we continue. We started circles. All of you are thorough. What is radius, chord, all those concepts? Okay, we'll continue from that. Before starting, we'll just once again revise. What are the things, students? First, we did what is radius. Next, a radius always starts from center. Any line which touches from one circumference to the other circumference, other part, what do you call? Chord, right? Chord. Everything is the chord. Even see, even if it passes through center, it's a chord. But what's the specific name we give? Diameter. And what's the formula for diameter? Diameter is not CR. 2R. 2 CR is crores. 2 times R. 2 times radius. Radius and diameter formula. Next, I told you chord. Next, we did arc, students. Arc. And we studied segment and sector theorem, right? Segment. What is segment made up of? Arc plus 2 chord. Sector arc plus 2 radius. Yes. Arc plus 2 radius. Yeah, Felicia, not Felicia. Yeah, Felicia, concentrate. Are you there online? I respond. Okay. Next. What are the two theorems I told you all, students? How did I teach? Center is equal to circumference. Circumference is equal to circumference. If I take this arc, A and B should be here. Now let us solve few questions based on this. I want you all to write the theorem, student. Find angle ACB. This is first question. So you all should know which theorem to apply. O is the center. Okay, let me write O here. O is the center. Let's try these two questions. Completed? All of you? What's the answer, students? First one, what did you get? I want all of you to answer yes. See, without writing statement, if the angle formed in the center is 60 on the circumference, yes, half of it. Very good. If you want to convert into statement, which is the angle formed in the center? Yeah, center is equal to twice circumference. Angle AOB, very good, is equal to what's the angle formed on the circumference? Is 60. Bring down this 2 divided by 2 is equal to AC. If it is MCQ question, you can directly write 30. If it is 3 marks question, this is how you write the statement. Make a note, all of you, 30 degrees. And don't write center is equal to twice circumference. You should write the complete statement. Once you write this, look here, next to this or below that you can write. Just copy from your textbook, students. You'll have that statement. Or tell me this and look at this and tell me angle formed on the, where is angle AOB? Angle formed in center, yes, is equal to, just tell me, convert this into sentence, is equal to twice, or you can write double, right? Yes. Or you can just write twice, students. What you write? Twice of angle formed on, what is that? Yes, circumference. That is what you have done, right? That is what I have written. Just convert into words. Mathematical statement into words. This is 3 marks question. Completed? All of you are done? Next. One angle is given. They've asked you to find ABD. Look here, I'll tell you how to attempt the question, students. Whenever they give to find ABD, the middle one is the angle AB. Where is angle B? Is it in the center or circumference? Where is it touching? Circumference. Then these two are the arc, starting point and ending point. Which is arc here? A and D. So whichever is touching the circumference, is there any center mentioned here? Center? No. The angles on circumference. What's the concept we use? Circumference is equal to, on the same arc AD, what's the other angle formed? Angle ABD. Circumference is equal to circumference. Which is the other angle? AC. If this is 60, this is also 60 degree. 60, but we don't write it in this. We write it like this. Is equal to 60 degree. Next to that in bracket you write, or below that you write angles formed on the same segment. Are they segment or sector? Both are segment, right? Yes. Chord is formed. There is no radius. Angle formed on the same segment. Same segment are equal. Did I explain cyclic quadrilateral? Okay, what about the angle formed on the semicircle? Right angle 90 degrees. Complete this. I will do some questions based on that. Okay, so be quick, students. Only then we can complete. Next one. I taught you semicircle or angle. This is a triangle circle. In this circle, imagine O is the center. This is PQ. If O is center, what is PQ? What do you call PQ? Diameter. Okay. If diameter, what did I tell you? Diameter will split the circle into how many parts today? Two parts, two equal parts. So from diameter PQ, if I draw a triangle like this, remember, what's this angle formed? 90 degrees. 90. Angle formed on the semicircle is 90 degrees. This is the theorem. Right? Even if they don't mention PQ as the diameter, students, what's the angle formed at R? 90 degree. If that is 90 degree, what is angle? What will be the value? I mean, what is PQ then? Diameter. Remember this. Okay, you should know even the opposite. If the angle formed 90 degree, then this line PQ is the diameter. In the same way, if I take another value like this, PQ is the diameter. From diameter, there is another angle PSQ. Even this is 90 degree. Is it clear? 90? Yeah, from this only we derive cyclic quadrilateral. What's the property of cyclic? All four sides should be touching circumference. Very good. And what's the other property? Opposite angle. Sum of opposite angles are 180. Can you see? If we add both, we are getting 180. Angle S plus angle R. What are we getting, students? We're getting in the same way. In the same way. I'll erase this. Okay. Angle S and R, I told you how we get 180. If I take this as diameter, all of you will respond. If RS is diameter, what is R cube? S. 90. Semicircle. On RS is the diameter, this is 90. If this is 90, on the same diameter, if another angle is formed on the circumference, both are equal. Both are equal to 180. I mean, not only 90, students, the concept of this is, if diameter is not given, the concept of quadrilateral, cyclic quadrilateral is, imagine there is no diameter. If this is 50 degree, what will be the value of Q? Not 50, not 50, they're not equal. What have I given here? I know you all will answer like this. Their sum should be equal to how much? 180 minus 50 is how much? 130. I have written is equal to the sigma. I have written P is equal to Q. No, how can they be equal? Okay, next. If angle S is 90, not 90, 80 degrees, what is angle R, students? And very good. Angle S plus angle R is 100. Angle S 80 degrees plus angle R as it is 180. 80 goes to the other side. R is equals to 180 minus 80 is how much? 100. And what about exterior angle? Did I explain? Exterior angle of a cyclic quadrilateral is equal to interior opposite. Straight. Okay, fine. And even this I would have explained. R, S, I'll take it as Q. Which is the exterior angle here? Q, I'll take it as Z. Which is the exterior angle, students? RQZ, right? RQZ. This exterior angle, which is a straight line here, students, which is a straight line? SQ and Z. According to straight line, with what are the two angles formed? One we have angle SQR, and what's the other one? R, no, no, RQZ. One is going on the left hand side, other one on the right hand side, right? See, one like this, and the other one like this. Both meet at a point 180 degrees, students. If this is 130 degrees, what is 180 minus 130? 50. So what is exterior angle value we got? 50 degrees. Is this clear? Using straight line concept? Imagine this is a protractor. Look at protractor. 50 plus 130 is 180. So from this straight line concept and cyclic quadrilateral, we got another concept. Exterior angle RQZ is equal to which one? Interior. Yes. First go inside and opposite. Angle P. Understood? Interior opposite. Okay, so this is what we did yesterday, students. Now the most important point, parallel line concept. All of you know what is parallel line? I'll start parallel. This was your 7th or 8th standard topic, but most important concept, parallel lines. So concentrate students, it's important topic. What do you mean by parallel line? Can any one of you answer what is parallel line? What do you mean parallel line? Very good. Two lines doesn't mean at any point. Example, the road. You have seen this road, right? The the roads. One vehicles will go this way, other vehicles will pass this way. Do they collide each other? No, right? They don't collide. That is known as parallel line. Parallel line, as Felicia told, it will never intersect each other. See, this is a parallel line. If I extend like this and if I extend like this, are they touching at a point? No. Two parallel lines. This is intersecting line. See, these two are intersecting. If I pull this and if I extend like this, are they intersecting at a point? A parallel line will always be straight like this, students. And how do they represent parallel line? Using these two arrows. Both the arrows are facing towards right hand side. They'll either give it like this or like this. Arrows will be facing towards same direction. First concept. Next, in parallel line, let me draw one transversal line, one cross line like this. Okay. Next, this point we call it as vertex. How many angles are formed here? This is one angle A, right? A, and from here to here another angle B. From this end to this end C, and from here to here what do you call? D. In the same way here, E, F, G, and H. So in the first line, students, let me take line 1, parallel line 1, and let me take line 2. In line 1, how many angles are formed? 4 angles, A, B, C, D. In line 2, 4 angles, right? So we should know the property. Whenever two parallel lines are given, what are their properties? First thing, if I take angle A as 110 degrees, everything is related to this parallel line, everything is related to the straight line, students. Straight line 180-degree concept. Look here, if I place a protractor here, don't you think A, B are in a straight line? If A is 110, how much is angle B, student? Can be equal. If this is 110, 180 minus 110 is 70. Now I place a protractor in this direction. B and C are a straight line, right? B and C. Like this, students. Look at this. Observe B and C, protractor. If B is 70 degree, what about C? 180 minus 70 will be 110. So what is angle C, students? Angle C is 110. 110. Now I'm going to place a protractor, which is a straight line now. Next one. Angle C and D are straight line. If angle C is 110, what about angle D? 70 degrees. Is this clear? Understood? So from here, what did we understand, students? Can you see opposite angles are equal? Right? So in one single line, the opposite, we call them as vertically opposite angle. See, if I take a triangle ABC, wherever a point meets, what do you call this point B as? We call it as vertex. So on the same vertex, if another angle is formed, what do you call them? Vertically opposite angles. Or remember alphabet X. Can you see I've drawn alphabet X using yellow line? Yellow line. Wherever, yeah, remember this today. Remember this concept. Wherever there is X alphabet visible, vertically opposite angles are equal. If this is 50, what about this one? 50. If this is 50, what will be the adjacent angle? Straight line. 180 minus 50 is 130. If that is 130, opposite also will be 130 degree. From this, we have understood vertically opposite. In the same way, if I take E as 110 degree, what will be angle F? 70 degrees. Okay, angle F will be 70 degrees. If that is 70, again angle 10, angle 1. E, F, G, H. What will be, students? Everything is straight line concept. H is 70. Again, can you see alphabet X is formed here? Second line, vertex, yellow line, second yellow line. Look at second yellow line. Opposite angles are equal. So in the first line, what are the vertically opposite angles, students? I'll write VOA, vertically opposite angle. What are the vertically opposite angles? Angle A is equal to angle C. Next one, angle. This is first vertex. Is this clear? All of you understood? Okay. Tell me the second vertex. Which two are vertically opposite? Angle A. X alphabet. Remember, angle E is equal to angle G. What do we call these angles as? Vertically opposite. So for vertically opposite, we are not comparing any line. We have just separated. One line is separate and the second line is separate. Done. Remember, you have studied corresponding angle. All of you remember the word corresponding angles? Seventh or eighth, you all studied corresponding, right? Corresponding angles. Can anyone tell what is corresponding angles? Line? Yeah, anyone can answer. Whoever knows it. Felicia, you know? Kefira, Felicia, Anam. Okay, vertically opposite, I told your students, we didn't compare. Fine, I'll teach. Corresponding angle is compare the first line with the second line. Tell me the same angle, same position. Angle A is in the same position to which one? E. The values are also same 110 and 110? Yes. Angle A is equal to angle E. Now let me take angle B. Angle B is in the first line, in the second line. Which angle? Very good. Tell me the other one. Angle C is equal to E. Angle D is equal to angle. When I'm writing, don't, when I'm teaching, don't write. Now write parallel line concept. Draw this diagram. Write what is vertically opposite corresponding angles. So for vertically opposite, we are not comparing the line, students, but for corresponding, same angle, different position. Angle A is similar to angle E. Complete this. There are two more things. Interior alternate, exterior alternate, allied angles. All of you completed? Vertically opposite corresponding done. Next, interior alternate. Can you tell me what is interior alternate, students? Interior alternate angles. What do you mean by interior? What's the meaning of interior? What's the basic meaning? Inside. Inside meaning what are we talking about? Parallel lines, right? What are the four angles which are present inside? CD, where ABCD? Inside the parallel line. E, E and F. Interior. These are the interior. What do you mean by alternate? Next to each other or one after the other? One after the other. Yeah, one after the other is alternate. Can you see angle E and C are equal? 110 and 110. Angles are equal. So what do you mean by that, student? See, the way it is opened, this distance for angle C and the way angle E is opened, the distance is equal. That's the reason 110 angle E, 110 degrees, angle E, 110, and this is also 110. So if angle is nothing but how wide the angle is opened, how wide the two lines are touching. So angle E is equal to angle C, interior alternate angle. Can you tell me the other interior alternate angle? What are the other interior alternate angles? Angle D is equal. If this is interior, can you all tell me what is exterior alternate? Very good. Angle B and H are 70, right? They're outside the parallel line. Are they outside? Okay. Angle B is equal to angle H. And angle A is equal to. So corresponding is done. Vertically opposite is done. Interior, exterior is done. What else left? Allied angle. Allied angle is the most important part. Completed? Interior, exterior alternate. Any doubts in this, students? Next, allied angle. Allied angle. Look, I'll tell you why parallel line is important. If I take a parallel line, this is a parallel, I'll extend. I'll draw a line like this. I'll name this as C. Observe this parallel line. This is a parallel line, and there is a line passing like this. Doesn't it look like a quadrilateral? Isn't it a quadrilateral? Right? It's a quadrilateral, student. So what is the value of D and E? Where are D and E? Inside the parallel line? Inside. D and E are not equal, but what is the sum of D and E? 180 degree. These two are known as allied angle. So inside any parallel line, where are the parallel line? Top, bottom, or left and right? Where is the parallel line? Top and bottom. Yes, top, bottom, like this. See, I'm taking this line, top and bottom. This angle is formed here. So remember this, wherever the parallel lines are given, top and bottom students, in the same way, can you see angle D is top and angle E is bottom? What angle D plus E is equal to 180. If I go on the other side, what about angle C and F? Sum is equal to 180. But C and F is not required. We'll take the right hand side part. Remember, these two are allied angles. What do you call them? Allied angles. Allied angles, or we call co-interior angles. Usually we don't mention co-interior, we call it as allied angle. What will be the sum, students? Sum of allied angle is 180. So let me erase, that's it, only allied angle. Make a note of allied angle. I'll give you a question. This is a, do you know the property of a rectangle? What's the property of a rectangle, students? Only opposite sides are equal, only that you'll know. The lines are also parallel, right? Opposite lines are parallel. And what about each angle? Each angle 90. All angles are 90. Even this is according to parallel line. According to parallel line, if this is 90, what do you call angle A and D? Don't we call them allied angles? Yeah, in a parallel angle, we'll call allied angle. Their sum should be 180. 90, that's the reason even this is 90. Okay, even this will be 90 and 90. Fine. So parallel line, allied angle is the answer, students. I'll give you a question now. Imagine. See, now it might be a bit confusing. Once we start solving the question, you'll understand why I total parallel lines, what's the use of corresponding interior alternate, vertically opposite angles. Fine. Let me take a circle. Okay, this is a circle. If all four sides are touching this, what kind of quadrilateral is this? Yes, tell me. Cyclic quadrilateral. Is any parallel lines given? Any parallel line? No parallel lines are given. Let me draw parallel line. According to parallel line concept, where are the parallel line? Top, bottom, or left and right? Top and bottom. Right? I'll give one angle 80 degrees. According to cyclic quadrilateral, if A is 80, how much is angle C, students? Angle plus opposite angles are how much? According to cyclic 180. If A is 80, what about angle C? 100. First concept. Cyclic quadrilateral is done. In order to find B and D, I mean, we need any one angle, right? Whether you find B and D, we need one angle. Use parallel line concept. If you use parallel line concept, what did I tell you? The Where are the parallel lines? Top and bottom. So which are the angles top and bottom? Angle A and angle D. Their sum should be how much? Yes, this is allied angle concept. So angle A and C are related using cyclic quadrilateral concept. Our angle A and D related for allied angles. This is the concept of allied angle. If this is 80, what is angle D, students? 180 minus 80 is 100. So angle B, you can use two concepts. Either you can take angle B plus which one? Angle B plus angle D. How are they related? Which concept? Not equal. Concept. Opposite angles of a quadrilateral. Or I can write angle B plus angle C. How are they related? Angle B plus angle C. Very good. Allied angle. Can you see parallel line is top and down? Therefore, these two sums should be what? 180. So it is better to use cyclic quadrilateral. Understood how to use cyclic quadrilateral along with parallel line concept? 100 degrees, 80 degrees. You don't have to write this. This just for practice. Don't write anything. Okay. So in parallel line, I'll teach you what is interior alternate. Imagine this is a cyclic quadrilateral. Then there's a last concept, isosceles. We'll do it later. Imagine this is a cyclic quadrilateral, students. In this cyclic quadrilateral, I'll draw this line. one transversal line like this. Okay. Now, if this is 80 degree, what about vertically opposite? I told you this also should be 80. If this is 80, according to straight line concept, imagine I keep a protractor. What will be the other angle value? 180 minus 80 is 100. If that is 100, this one is also 100, right? Okay, which is known as vertically opposite, students. Which is vertically opposite in a parallel line? I mean interior alternate. Which is interior? Interior alternate. This 100 will be equal to this one, right? 100. This 8 equal to this 8. Use the same concept here. If I write this as 50 degrees, what will be this value? 50. Interior alternate angles. So this will be 50 degrees. Is it clear? Understood? When there are parallel lines, yes. When there are parallel lines, 50 degrees. In the same way, if this is 60, what about this one? This also will be 60 degrees. Okay, that is known as parallel line. What interior alternate position, interior alternate angles. Right. Next, imagine same question. They give you 50 degrees here. Okay, enough. That is enough. Interior alternate is done. Exterior is done. Types of triangles. This is the last concept. All of you know what is isosceles triangle, students. Yeah, what do you mean by isosceles triangle? Sides are equal, you'll get zero. Any two sides are equal. So those who don't know, students, because all are new. Other students, last batch I taught him. I think Lima Bebley I taught you all, right? See, triangle. See, basically it is split into four, students. Write it later. I'll give you time. First one is scale in triangle. What's the first one? Scale in triangle. Second one is isosceles triangle. Third one is equilateral. Fourth one is right. Yes, right angle. So I'll explain. Listen. Before that, if I take any triangle, irrespective of isosceles, equilateral, scale in or right angle, that doesn't matter. Sum of all three sides of a triangle. What did I tell you? Yes. Angle A plus angle B plus angle C should be equal to 180. Yeah, we are aware of this one. So what is scaling? A scale in triangle, none of the sides are equal, students. None of the sides and their angles are equal. A, B, C. If you take this will be 5 centimeter, 6 centimeter, BC will be 7. If you take their angles, one will be 50, one will be 60, and the other one will be 70. Any of the angles equal? No. Any of the sides equal? No. So a plane figure, a plane triangle is known as scalene triangle. Next one, isosceles triangle. A, B, C. Any two sides are equal. What do you mean by that? If I take 5 here, BC is 5. Which two sides are equal? Yes. They usually give the mark like the second excuse me. The second concept in this, the side equal to AB. Just put a line like this. Which is the angle formed here? Angle C will be equal to what is the angle formed opposite to this line? Angle A. They both will be equal. So the meaning of that is if angle C is 50, what about angle A? 50. Yes. Make a note of this. Their opposite angles will be equal. This is cyclic quadrilateral. How will you find angle B? Can anyone answer? If both are 50, what is angle B, students? Which concept we use? Sum of interior, right? Very good. 180 minus 100, angle B will be 80. So cyclic is isosceles is the most important concept in this one circle chapter. Not only circle, in entire geometry, isosceles and equilateral. When equilateral they don't give much, but isosceles you get lot of questions. Right triangle, write all the four types of triangles. All of you completed? Done? Equilateral, I'll tell you what is it, students. So try one question and I saw this. Try one question. Angle ABC is given. I want you all to find angle A. Try this question. Yes, what's the answer? Which two sides are equal here? No, no. AB, side AB is equal to side. Right? What is the angle opposite to AB, students? No, no. Angle. Angle C. What is the angle opposite to AC? Angle B. If B is 70, what is angle C? 70. If both are 70, 180 minus 70, what? Understood? Yeah, this is known as isosceles, 40 degrees. Equilateral, we all know, all three sides are equal. If all three are equal, let us take x, x and x. 3x is equal to 180. What is x value? 60. Angle A plus angle B plus angle C. If you add all three, should be 3x, students. So equilateral, just ignore all this. Remember, each angle of equilateral triangle is how much? 60. Just draw equilateral, write all three angles 60 degree. Ignore the calculation part. Write 60. All three sides are equal. Then what about right angle, students? What do you call right angle? Any one angle will be equal to. Example we use in Pythagoras theorem, trigonometry, 90 degrees. See, those who join, for all of you, I didn't start trigonometry, heights and distance. That would take some time. Completed, done. Any doubts in triangle, students? Do you have any doubts? Okay. Well, now I'll give you a question. We'll put all four together. Cyclic quadrilateral, triangle, parallel line together. Yeah. What kind of diagram is this when all four sides are touching? Yeah, it's a cyclic quadrilateral. Very good. It's a cyclic quadrilateral. Now, what kind of lines are these? Yeah, it's a parallel line, right? Parallel line. If I place a center here, okay, center, student. This is center. I'll ask you a question. How do you find angle BAC, students? Where is angle? O is the center. Where is angle BAC formed? All of you respond. Where is angle BAC? Where is A formed? Center or circumference? It's formed on the circumference, right? Then which is the arc? If A is the circumference, it is arc. Arc meaning the other two. Other two is the arc, students. B and C is the arc, right? So on the same arc, where is the other angle formed? Where is the other line passing? BOC. Where is BOC formed? Center. So which formula can we use to find BAC? Center is equal to 2 times circumference. BOC is 100. How much is BAC, student? 50 degrees. Did you understand? Okay, this is how you do. BOC is equal to 100. Bring this 2 down. 50. So when I take BAC, remember tomorrow we'll start solving. A is the angle formed. These two will be the arc. B and C is the arc. Are they on the circumference B and C? They are on the arc. So angle BAC will be half of it. What is angle BAC? 50 degree. Now that is fine. Okay, the actual question is, see, this is the actual question. Angle BAC is equal to 80 degrees. Angle BAC is equal to 40 degrees. Okay. Angle BAC is 40. I want you all to find angle BOC, students. First question, BOC. How will you relate it? Tell me, where is angle BAC formed? Center or circumference? Circumference. Where is angle BOC? Center. Which formula? Which concept we use? Center is equal to twice circumference, right? That is first question. And we need to find angle OBC. For angle OBC, start from O, B and C. Right? OBC. This is the second one. And the third one is OCB. OCB. First, if angle BAC is 40, what about angle BOC, students? What is double? 2 times 80. Right? So we have entered into this triangle. Tell me what kind of triangle is this? Who can answer? Think and answer. It's inside the circle. This is where you relate kind of triangle. We have only 4 triangles. Is it 90 degrees right angle? No. Is it equilateral? For equilateral, all 3 angles, what did I tell? Equal. Is this equilateral? It's not a right angle, it's not equilateral. What are the two? Scalene and isosceles. Tell me, figure out which is scalene is the right. I'll give you a clue. Connect it with the circle. According to circle, what is O and B? According to circle. Very good. If radius is OB, what about OC? Are radius equal? What kind of triangle? Isosceles triangle. Yeah, this is how we'll have to think, students. Just memorizing concept, whatever teacher does in board, copying that will not work. You have to think like this. What Lima told was correct. If it is radius, 2 sides are equal. If these 2 sides, which 2 angles are equal? Angle B is equal to angle B. If it is not given, take it as x. What's the angle formula? Angle O plus angle B plus angle C is equal to 180 degrees. Tell me the answer. What do you get? X plus x is 2x. 180 goes to the other side. 180 minus 80 is how much? 100. 100 divided by 2? 50. So what's the answer for these 2 angles? 50. So this is how we connect it. See, I taught you all isosceles. But directly did they give isosceles? No, they won't give you all. You should connect it with the circle concept. Okay, so this is how the concept of circle, isosceles, right angle, everything works, students. So concept wise, I've completed everything. Tomorrow we'll start solving the questions. Clear? Okay, tomorrow we'll start. Any doubts so far? Whatever we have done?